CityScope JavaScript. In the past couple of months, we've been developing kind of a new approach for CityScope, which is focused on having everything running from the web. The key point is that we can, like anywhere in our history, develop CityScope in many different ways and have components that are usable by other developers. In that sense, the ecosystem that CityScope.JS is proposing, at least, is scanning to begin with, sending it to the CDIO server, which is something we want to talk about later on, but is getting there, becoming more and more stable and workable, and we're all kind of working with it already. And then we have all the parts of the data visualization and projection, which are on the table itself. Now, there is already a kind of an up and running demo table up here in the demo space, which is using all of these tools together, and again, focusing only on a JavaScript and web-based approach. We're scanning, we are sending to the server, then we're projecting it back into the table, either through projection or through data visualization, and again, all of that is from the web. Now, as we do know, the holy grail of CityScope is about the scanning, so the ability to recognize changes over time. And this is why today I don't want to focus on the other parts, I just want to focus on the scanning and sending it to CDIO, because I think this is adamant. This is a key part of what CityScope is all about. The scanning part that we've been working on in the past few months is, I think, pretty robust and easy to use. I think the biggest advantage is completely platform agnostic. So in the past, we had to force ourselves to either strong computers or specific computers. I'm running here an example of the CityScope.JS on a Raspberry Pi version 2, which is the older Raspberry Pi, and it's running at about 40 frames per second. And this is yesterday running from my phone, scanning a table of 12 by 12 at about 16 or 20 frames per second, meaning you can run CityScope on your phone. The concept behind that, and I think that the reason why it's quite quick, is because we're keeping on using the good old Legos in a 4x4 pattern, but then instead of scanning 4 bits of data, meaning 4 bits together, which we used to do in the past, here we can scan basically 1 out of 16. So basically each pixel, each Lego brick of 1 by 1 is becoming key for the recognition, and then we can have as many patterns as we want, and eventually it's 2 in the power of 16, so it's about 65,000 unique tags, or 16,000 unique tags if we count for rotations. The code base for that is 500 lines of code on basically one script. You see 700 because there are a lot of comments and explanations. So basically, if you read through that, you would see it's a watershed development. I want to spend 5 minutes just to show you how it works and kind of give you the 5-minute CityScope deployment. Like everything else, we start with our front page, CityScope GitHub. So everybody who goes to our GitHub gets there. Scroll down to CityScope.JS. And one, I think, cool thing is that you do not need to clone this repository or install any software. You literally just click on that, click and you're in. What you should get at that point is basically your camera showing here. It really depends on which operation system or browser you use. There shouldn't be a problem on Firefox or Chrome, but yeah, if you use Internet Explorer on a Windows 8, you might have some issues. It's better to be uploaded and updated. There are not many options at that point. What you see here is frame rate, some kind of logging, and basically a call for starting here. So when we ask for start here, we basically want you to upload a specific file, a JSON file, that is holding all the specifications of that table. And it's important because each table sits physically in different places in the world, and each table has its own specifications. I'm not going to go deep into that at the moment. I'm just going to load a file. When I'm loading the file, you can see that some kind of scanning already starts. That's because I already started the table before, but you can see that the grid here doesn't fit my potential table grid. So what I'm going to do, I'm just going to do reset and clear keystone. I'm going to load this JSON file again, and that will prompt me to do scanning. You can see there is some kind of magnifying glass that helps you to find the corners. You do up left, up right, and left down right. And you can see now that this is what basically the computer sees. So these are the scanned items from that computer, from that table. Then if we go into CDIO folder here, you could see a few items. One of them is the rate of sending to CDIO. So currently it sends this information every second. So every change every second would go there. You would see that there is a resulting table, which is a quick visualization of what this table is. And you can see some of the types that are being recognized or not. And this is depending on the types we have set before, and I'm going to go into that later. And you can see the row API, which is, I think, the most important thing. This is basically what CDIO server is getting from that scanning. And at the time, you can see that it gets basically -1, mostly number 2 somewhere here, which is a recognized tab, and so forth. So eventually, we recognize that basically all of this data is now shipped into the server. And by going into what the server would get, we would see that this table now appears in our server. So we'd see a table called test. I'm not sure exactly where it is. It's here. And we have 4x4 grid with some kind of quick visualization